Alrighty, welcome to part two of factoring. In class earlier, we talked about what factoring was in terms of monomials. So I just asked you a simple question of, what are the factors of 12? And you told me all of the things that you could multiply together to get 12. So that would be 1, 2, 3, 4, 6, or 12. Okay, and then I said the same thing, except then I gave you a variable. So I said, what are the factors of 16x? And so we started with 16 and we listed those out as 1, 2, 4, 8, 16. And then we just kind of tagged along whatever variables we had there as well. Okay, and then we said that factoring was basically breaking a polynomial down into its factors. And I have a feeling that factoring monomials is probably an okay thing. But now what we're going to get into is factoring binomials. Okay, and it's done a little bit differently because now we have two terms. All right, and so just for a second, I want you to think back to the idea of distribution. So let's say that I had 3 times and then 2x plus 1. Okay, these are two things multiplied together, right? We're multiplying a 3 and we're multiplying a 2x plus 1. And if we're going to multiply them, we distribute. So 3 times 2x is 6x, and 3 times 1 is plus 3. And so we said the product was 6x plus 3. All right, so the factors of 6x plus 3 then are 3 and 2x plus 1. And so this is the goal here. The goal is to be able to go from something like this back to where it came from. Okay, and we're going to put that into words in basically saying with a star that factoring is the opposite of multiplying polynomials. And I'm going to put in parentheses there distribution because that's kind of what we've been talking about. Okay. Factoring is the opposite of multiplying polynomials, which is what we call distribution. Okay. So let's go ahead and look at another example. We'll call this example 3. Okay. And in example 3, I want us to factor 6x squared plus 3x. So I want to know, where did that come from? Okay. In other words, I'm going to ask, and I want us to write this question down in words because I think in math sometimes we forget what we're trying to find. We forget what the question means. Okay. And so this question is going to say, what two things could I multiply together to get this product of 6x squared plus 3x? That's essentially the question that it's asking. Okay? And so I need to think about, well, if I need to get back to here, right, through multiplication, then whatever I multiply, right, has to get me to 6x squared and 3x. Well, if you think about going backwards, right, we need to think about something that divides both of them then. So if we're going to multiply to get here, we have to divide to go backwards, right? Those are inverses. And so we need to think, okay, well, what divides 6x squared? And essentially the question that you're asking there is when you're asking, well, what divides 6x squared? We're asking, what are the factors of 6x squared? And 6x squared have factors of 1, 2, 3, and then we'll just keep the x squared as x squared. Also, there's a 6. I forgot about the 6. Okay? And 3x, the factors are 1, 3, and x, right? And so what we want to look for here is we want to look for the thing that's going to divide them both, right? We can't just divide 6x squared, and we can't just divide 3x. We need something that's going to divide both. So the goal here of factoring is to find the greatest common factor, or GCF, of both terms. Okay? And so in this case, we need the biggest thing that they have in common. So I go through my numbers, and it should be pretty clear that 3 is the greatest common factor. Okay? But now with variables, what we have to understand here is that x squared and x, so this term here has basically 2 x's, if you will, and this term here only has 1x. We need to take the biggest number that they both have. And in this case, there's just going to be 1x. And the reason why I can't take 2 is because this one only has 1. Okay, so you got to take the biggest one that they both have. How many do they have in common? Okay, so the GCF here is going to be 3x. All right. And then once you take out the GCF of 3x, okay, then we know that we can multiply 3x by something to get back to here, right? That's the idea of a greatest common factor, is that it divides our polynomial. So we ask ourselves, well, we take 3x and we multiply it by what to get us back to 6x squared? In other words, what is missing? Okay, so we take 3, think about how to get from 3 to 6. Well, that would get us to a 2. And then we've got an x, but we need to get to x squared, so that means we're missing an x. Okay, and then the sign stays the same there. And so now we look at the second term. Well, to get to 3 to 3 would need to be a 1. And then x and x we already have, so we're good. Okay, now the really cool thing about factoring, no matter how difficult that it gets, the really cool thing about factoring is that you can always check your work. Okay, so that's what we're going to do next here. And I'm going to put a little star above it and say check, because you guys get confused on what the actual answer is and what's me just checking my work. Okay, so we think that the answer is 3x times 2x plus 1. But we can check our work by using distribution, right? If factoring is the opposite, then we can check our work by actually doing that process. So we've got 3x times 2x. Well, 3 times 2 is 6. And x times x is x squared. And then 3x times 1 is 3x. Let's go back. Oh, that is exactly what we should have gotten. Good. So your answer is this right here. A lot of people have a tendency to square or circle that one right there. That's the problem. That's not the answer. This is the answer, and this process here is just me checking my work. Okay? Let's do one more example. We'll call this example 4. Okay? And in example 4, I want us to factor 2xy plus 8x squared. Okay? So we're going to start out the same way. We need to ask ourselves, well, what even makes up these terms? Okay? So with 2, we've got 2 and x and y. And with 8, we've got 1, 2, 4, 8, and x squared. Okay, so we take the biggest number that they have in common. Could also be a 1 there if you wanted it. We would take out a 2. Okay, so the GCF is 2. And then it looks like they both have 1x in common. So the GCF is 2x. Okay, so then we say, okay, well, if we can take a 2x out of both of them, let's see what we would have left. So if I look at my first term here, the thing that's missing is a y. And here, it looks like I would need to multiply it by a 4 to get to the 8, but then we're also missing an x. Okay? So I think that this is my answer. I think it's my answer. Let's double check my work. Okay? So I come down here and I say, okay, let's check it. If I think the answer is 2x times y plus 4x, I distribute. I get 2xy. I distribute, and that gives me an 8x squared, which is what I should get back to in the beginning. So that means that the answer that I have found is correct. Okay? This is the very, very beginning stages of factoring. All right, just factoring out a GCF. It's going to get more complicated and we're going to have more steps. But I think this is a really good place for us to stop here. And then we will do some more practice with this in class next time. So, thanks for watching.